Next up is Nathan Chan from Resource Economics. He's assistant professor there, received his Ph.D. from Yale, M.P.A. from Columbia, a B.S. from Caltech, was at Colby, I believe, before coming here. Yes, so welcome to public university life. It's great to have you. His primary research interests are the fields of environmental economics and public economics. Nathan likes to study what we call commons problems, situations where the participants acting in their own interest aren't necessarily creating the best outcomes from the group, something which he'll have no shortage of issues to solve. So his talk is conservation, conformity, and machine learning. So please welcome Nathan Chan.
It's like set to automatic.
Oh, is it?
It was.
Okay. There we go. All right, so this is a research project that's about conformity. So we have two motivating questions. First of all, we're trying to see if we can detect conformity in economic behaviors. Second of all, we want to figure out, can we actually determine how much conformity is worth to people? The context, we're going to study conformity in a very specific context, that is residential landscaping decisions. There's a few reasons for this. One is that residential landscaping decisions are highly visible, so we might expect that there are norms that are emerging around it, and you might want to look like your neighbors. Secondly, water conservation is extremely important, especially in arid cities around the US, and the landscaping decisions that homeowners take have a huge impact on how much water they use. Thirdly, what we have is a very, very unique data set, high-resolution data set that we're going to be able to exploit for the purposes of studying conformity in this very specific context. So let me tell you about that data. What we have is ultra-high resolution data, the pixels on these aerial images that we have. So basically what happened is we were partnering with the city. That city hired people to fly planes over the city once per year over the course of 10 years. They took super high resolution aerial photos of the landscapes there, and we can actually use those landscapes, use those photos to classify people's landscapes. The way we're going to do that is we're going to use a machine learning algorithm. What you see on the left-hand side here is the raw images. So here's a bunch of houses in this anonymous city, and we can see their landscapes. We use a machine learning algorithm, and the machine learning algorithm is telling us which parts of the landscape appear to be green, lush grass and green trees, which are going to be very water intensive, versus other fixtures that might be less water intensive, such as xeric plants or other things people might install. One thing you might notice is that the machine learning algorithm is imperfect in classifying it. To the human eye, we can see there's some systematic errors. For example, in between houses, there's some shadows there, and it's having trouble picking up what we can clearly see as grass. So we further do a correction where we gather water billing data from this city and cross-reference it to kind of correct for any systematic errors in the machine learning algorithm. With that in hand, what we can do is we can classify your house's landscape, and we can compare it to all the landscapes of the neighbors that you might have, and from that we can create a distance measure. How similar, how different are you than those around you? What that's going to do is we can merge that distance measure with local transaction data, so we can see when homes are being bought and sold, and we can match that to how similar or how different your landscape is. We can match that with a regression framework. So basically what we're doing is we're trying to see how your property value or how your sales price is going to be affected by your disconformity from your neighbors. So how different is your landscape from your neighbors, and how does that affect your sales price? We're also collecting lots of data on lots of different variables that are going to help us control for other confounding factors. So ultimately what we're after is the effect of this key variable delta, which is how different are you from your neighbors, and we're going to see how that affects your ultimate sales price. When we run the regression, we get some simple results. So we run it in a lot of different ways with different controls omitted or included, but essentially we get the same answer no matter what. The main thing that you should look for in this is that we're running this in different ways, and we're seeing the coefficient estimates on delta. What we see here is they're universally negative. What this is suggesting is if you have a different landscape than your neighbors, you're going to suffer in terms of your property sales value. What's also notable here is that we do this by splitting it out into your on-street neighbors and off-street neighbors, and we see that this effect only plays through your on-street neighbors, which is further confirmatory evidence that this is probably a conformity effect. We expect conformity to work through those who you're most visible to and who are most visible to you, and not to your neighbors who might be behind you that you can't see. So all of these things are suggestive of conformity. We can also quantify what these coefficients mean. So to give you a dollar value for this suggests that if you have a 1 standard deviation difference from your neighbors, that's going to cost you about $2,000 in your sales price. So we've identified conformity in large-scale observational data. We can also put a dollar value to see what kinds of trade-offs are people willing to make to look like those around them. Why does this matter? So it's kind of interesting from an economic perspective, but it also matters for policy. So there's a lot of conservation policies, not just in water conservation, where we try to pay people to take on conservation behaviors. In the water conservation landscape, a lot of cities, what they're doing is they're actually paying people to convert their landscapes from lush green grass that takes lots of water into xeric or dry landscapes. Here's an example from LA. They're paying about $2 per square foot. Every square foot of landscape that you're willing to convert into low water use fixtures, they're going to pay you $2. What we find is that these conformity effects, when we kind of combine this with a theoretical model of how people behave, these will actually create some stickiness that will undermine the efficacy of these policies. You can imagine that if you're being offered a payment but none of your neighbors are changing their landscapes, that's going to create a friction where you might be less willing to change. Because of this, we estimate that the financial incentives that are going to be offered might actually need to be about 67% larger to achieve the same effect when conformity is relevant versus in cases where conformity does not exist. So conformity matters. People are willing to pay for it in their property values, and it can also undermine well-intentioned policies. Thank you.